Hi. Earlier today I came across this nifty little program to display Lissajous figures on the scope of SonicPi. Here I've detached the window for the scope and I've set it up to be square, equal X and Y axes. And this little program came from the website of a Japanese user of SonicPi called Hiroshi Tachibana. The website is given here, and you can have a brief look at the program here displayed on the site. The site is actually in Japanese, and if you want to read any more of it, you can actually just put it into Google Translate and it comes out quite well. And he's got some very nice ideas. I've used some of his stuff before and also worked from that. In particular, he produced the script to convert MIDI output into SonicPi notation. But luckily this particular program, because there's a screenshot of it, you can actually see the code for it straight away there. Excuse my emails coming in there. You can see the program there, and if we now get rid of Firefox, here we are, let's hide it. You can see that I've copied the same program down here. This is a very nifty little program. It's only about 4, 5, 6 lines long, and it consists of some pairs of frequencies, 600, 600, 600, 550 and so on, and a loop which goes round and plays 2 notes together, one taking the frequency from the first item in each pair, and the other the frequency for the second item in each pair. The first one is played at pan -1, in other words full on the left channel, and the second one is played at pan 1, i.e. full on the right channel. And the result is that if you look at the Lissajous scope trace, where you feed one channel in the y-axis, one on the x-axis, you will actually get a Lissajous figure displayed. So if I run that, you can hear the sound effects it gives. Second one, the third one, fourth one, and the fifth one, and this just continues and cycles down in an infinite loop. Now, one nice thing about it is that the timing of these are given so that the next note starts, or the next pair of notes starts before the previous one is finished. Because if you look at the timings for the 2 notes played, there's an attack of 1, there's a sustain of 2, and there's an implied release of 1, which is the default unless you specify otherwise. And so there is a time of 2 + 1 + 1, which is 4 for the total, and they are separated from coming in by 2, which means that you don't get a straight Lissajous figure displayed. It actually merges from one to the other. If I was to change this time up to 4 seconds and run the program again, you see we go straight up to the stable Lissajous figure for each pair of frequencies straight away, just as the amplitude increases from the attack and then decreases with the release at the end. Now, looking at this, I thought, well, this is quite a nice program to play around with. Wouldn't it be nice if we could change the attack and the sustain and perhaps the sleep time and also the tempo by changing the bits per minute as we went round? And also, so because we didn't want it to get too boring, if we actually changed the frequencies on subsequent passes as well, which you can do by using a transpose function. And I thought, having played recently with TouchOSC, and you can see my TouchOSC screen displayed down here on what is in fact a window for QuickTime about to try and do a record. It's actually on standby, it's not started doing so, but it does give a convenient way to display the screen of TouchOSC, which is running on my iPad. And I thought that if we could arrange these so that we could change these settings, the beats per minute, the delay time round the loop, this sleep 4 or 2, which it was previously, and the volume of the 2 waves, they're set quite high here because we're using the sine synthesizer, which is not a particularly loud one. and if we could change the attack, sustain, release, and maybe the synths as well, then we get quite a nice little system which we could use to explore how these patterns are generated. And so in Delia-Smith's pattern, we'll just move the SonicPi window up a little bit here, and I can change to the next buffer where you can see the resulting program. It's slightly longer than we had previously, but the main part of the program is almost exactly the same as before, except that the attack settings, the volume setting, the sustain setting, and I've actually brought in the release setting, and in fact the plan settings are all governed by variables, as is the delayed time round the loop. And these are going to be governed by means of this second control loop down here, which makes use of the features which are in the development version of SonicPi, which is going to be due out at the end of this month, which allows it to process MIDI signals and also to respond very easily to OSC signals, and also to send OSC messages. And so it's a very convenient way for it to interact with TouchOSC. The first part of the program is just setting up various variables which are used. We first of all set the address of my iPad and the port at which TouchOSC is listening for OSC messages to come in. This flip variable is going to be used to make it slightly more interesting, that each time it's gone through one complete range of the pairs of frequencies here, and I've actually added to them and changed them slightly so that we've got 7 in each iteration. Each time it's finished one of those, it's going to flip over the pan settings of the two play commands down at the bottom here, and this will swap over the X and Y axes so that we will get actually the whole pattern flipping over, with what was displayed on the X-axis now displayed on the Y-axis, and vice versa, just to add a bit more interest. And the second thing I've done is to add a range of transpose settings, so that as we go round the loop, each time it's played one note, it's going to change the transpose setting. It's going to go up 5 notes and down 5 notes, and then down from where it started and back up again. So that way we're going to get slightly more interest in what we're listening to, although it won't actually affect the patterns, because since both frequencies are going up at the same amount, the Lissajous pattern you get will be exactly the same. Then we're setting some initial starting values for the beats per minute, the tempo at 60, the delay time around the loop is 2, the volume is 3, the attack is 1, the sustain 2, the release time 1, and the initial synth is the sine synth. These MIDI vowels here are going to set the positions of the sliders on the display so that they will correspond to those settings the first time round. And these 6 or so OSC messages are going to set these values on the various displayed numbers which will appear in the boxes labelled V, BPM, V delay and so on down at the bottom when we run the program. So I think probably having said that, it gives you a brief indication of what's going to happen. We can play the program and get it working. I've also changed from using 4 next loops to using a live loop for the whole setting, and using tick signals to move on around the ring of pairs of frequencies and around the ring of transpose settings as we go on. And you can see that the transpose settings are actually going to use a tick which is going to run at the 7th of the rate of the main one, so that every time we played all 7 of the pairs of frequencies, we will move on to a different transpose setting. So let's start it running, and then we can experiment and see the controls that we've got. See that when I pressed it, the picture of the TouchOSC on the bottom right of the screen has changed to reflect the starting values, and you can see we get some rather nice patterns as we move through these. What I'm going to do is to make some changes now. I'm going to first of all slow things down a bit by reducing the tempo to 30. I'm going to change the display time. The delay time around the loop to say 3, which means that it will stay stationary at each set Lissajous figure once it's moved from one to the other. But if I reduce the attack and release times, it's very quickly going to change from one to the other, like that. Here we go, first one. The next one. Let's speed it up a bit. As we go through the second time, you'll see that the nodes are in different positions. You try and memorize the patterns that you get the second time round. Now it will be slightly different. Let's change these to make it a bit faster here. Go down to 2. And then we go right up to the top for all of these. And all up at the top. So the volume to fit better on the screen. Change the synth. So I hope you can see it as I've been altering those various controls. You can have a very, very wide range of patterns and sounds produced from this program. It's been great fun to develop and play with, and I hope you can see from the program over here on this side of the screen that it doesn't really take an awful lot of programming to do so. In fact, a lot of the program is very repetitive. Down in the controls section, which will be new to most people who haven't used any of the development stuff, you can see, first of all, we've got this command use real time, which is going to, let's just reduce the volume of that a bit, which is going to give a very good high response time to this loop. Secondly, this sync command is what's going to actually read MIDI control changes coming in here. The stars give me wildcards effectively, which means it will make through a MIDI input from any device on any port and any channel. Here I've only got one MIDI input device, so that's fine. And then we simply get two numbers returned each time you get a MIDI control change detected. The first one tells you the MIDI control number, that's in B0, and the second one, which is in B1, tells you the value that's going to be set to. And so I've got several controls, and these are numbered 1, 2, 3, 4, 5, 6 across here. And so here we've got a case statement which deals with each one of those in turn. The final one is going to deal with the 6 position switch down at the bottom, and that is actually got MIDI control numbers 11, 12, 13, 14, 15, 16 on it. And so they are all dealt with by the same part of the case statement, because only one of these switches can be acted at a time. It is called an exclusive toggle switch, and so when you click on one, it turns all the others off. And this little thing here which says if B1 is not equal to 0, ignore it. It's only going to deal with turn on signals coming from each of these controls. It's going to work out which one of these it is by subtracting 11 from the number that's returned, and that will give us a lookup into the list of synths which are up at the top here. There they are. If it's 0, it'll read sine. If it's 1, tri, saw, square, FM and pulse. These synths are chosen so not to be too complex in waveform, which will give a reasonable Lissajous figure. You get pure ones obviously with the sine wave, but triangle and saw and square give slightly more jagged ones, and FM and pulse give slightly more exotic ones, which are still not too much of a mess, so you can get some reasonable pattern. So I hope you've enjoyed watching this program, and it gives you an inkling of what's to come when this new version comes out very soon. Thanks for watching.